just how to prove that a triangle is right.
Are you just gonna walk in?
Yes.
Yes, we're just gonna walk
We
in.
just need help.
Okay.
Alright.
My name's Prince, and I'll be showing these two kids, Andrew and Taylor, how to prove the Pythagorean theorem.
And I'll be constructing the right triangle.
Zuzi on the track.
Taylor.
Yeah.
How do you know that's a
Oh shoot! I'll show you that soon. So let's erase that so we can actually prove that it is a right angle. So we will label these sides A and B, and this side C.
what do you call it?
This is the hypotenuse, and these are the legs.
You're going to prove this triangle is a right triangle by a series of transformations and rotations. So you can take this triangle and rotate it like this. Then another rotation. Then one more.
Now that we have our square base here, going to label our angles here, X to Y. And same for, these are the same triangles. There's a 90-degree angle because this is a quadrilateral.
Okay guys, now that we know that x plus z plus y equals 180 degrees, then that just gives us one step closer to proving that this is a right angle. So we know that x, z, and y are supplementary, so they add up to 180. And we know that z is a 90-degree angle, so we can put that in an equation. Put x plus 90 plus y equals 180 degrees. So in order to get x and y alone, we would subtract 90 from both sides, and we would get x plus y equals 90 degrees.
X plus y equals 90, and x and y here. That means these two angles add up to 90, and that means the third angle has to add up to 180. So now we know that this angle equals 90 degrees. Now that we know x plus y equals 90 degrees, and all three angles in a triangle have to equal 180 degrees, and 90 plus another 90 is 180 degrees.
Zuzi on the
Next
track.
step is to find the area of this inner square.
Which inner square?
This inner square, the one created by the hypotenuse. We all know length. In this case, it is c times c, or c squared. Now we gotta find the area of the triangles and add that to the area of the smaller square to find the overall area of this big square right here.
We all know that the area of a triangle equals base times height over 2. And since there are 4 small triangles, we would multiply this times 4, base times height over 2, or over 1. BH over 2, 2BH over 1. So in this case, the triangle's base and height are labeled AB.
Area of the inner square and the area of one triangle. Now we know the area of the whole square, which is 2AB plus C squared. So we know that it's length times width. So this is the length. So we will be doing A plus B times width, which is A, and B. So times A plus B which is the same thing as a squared plus b squared. You already know that the area of the triangle is 2ab. Add that in to the area of the big plus 2ab.
So since these two equations both equal the area of the big square, that means they should equal each other. A squared 2ab. We'll subtract 2ab from both sides, and you get b squared equals c squared.
This equation proves the Pythagorean theorem, but
the Pythagorean theorem is only true if the triangle is right.
Stacking my bands all the way to the top, all the way to my bed falling over. Every time that you leave your spot, your girlfriend call me like, come on over. I like the way that she treat me, gon' leave you on.